Question 20. A health fitness research group wishes to estimate the mean amount of time in hours that members of a fitness center spend each week exercising at the center. They want to estimate the mean with a margin of error of 0.45 hours. So that's going to be your margin of error with a 98% confidence level. Previous data suggests that mu, sigma, is 2.2. This is the population standard deviation. Remember, guys, why do we use the t-distribution? Because we don't have the population standard deviation. So in this case here, we are provided that. So in this case here, we're going to use a z-distribution. We want to know the following is which of the following is the smallest sample size that meets these criteria. So we can do this because the margin of error for a t-distribution is going to be the critical value t star times your standard error, which is the standard deviation divided by the square root of n. But because we can use z star, and you can't do these with t star, it's impossible. It's like two variables to solve for. Well, I guess you can if you set up a system of equations, but no. And you're going to take that sigma and you're going to divide it by your sample size, but we don't know our sample size. But we do know that it has to be less than or equal to our margin of error. So that's the equation we're going to solve. Now, we're going to find that z star using our table B or our inverse norm. First, let's just talk about table B. That's for me the easiest way. Just look on the infinity line and find your confidence level. So our confidence level is going to be 98%. Infinity is the normal distribution. So we're looking at 2.326. And that's the easiest way to get it for me when I have the table. But if you prefer to use your calculator, you will use inverse norm. Now, inverse norm, remember, has a center option. So if you're just going to, like if you're defaulting to the left, then you'll have to do what you do with the t-distribution where you average that with 1. Keep it at 0 and 1. So you can do that here and get 2.326 that way. Or you can do the center option since we have that and just leave that at 0.98 and click on center. And older calculators don't have this option. So use the first way if you don't have that. And you have this 2.326, negative 2.326. Obviously, use the positive value when you're calculating this. So now that we have that, we can go ahead and solve. So 2.326 is going to be your critical value. That's going to be your z star. And that's going to be multiplied by 2.2 divided by the square root of n, which is less than or equal to your margin of error. All right, so now you can plug your answer choices in if you want, but let me just kind of show you how to set this up in case it happens on a free response and you don't have answer choices. But feel free on your multiple choice to just plug it in. So I'm going to do 2.326 multiplied by 2.2. I'm going to bring the 0.5 down below. I'm going to bring this square root of n over here. So really what I'm doing is I'm switching places with those two things, okay? Easiest way to do that. And then beyond that, you can calculate this and then undo the square root by squaring. So just calculate this number here, square it, and always round up. Never round down. So round up, we're trying to see greater than or equal to in this case here. So I'm going to do all that in my calculator. So 2.326. I'm going to clear that out. 2.326 times 2.2 divided by 0.5. I'm going to hit enter, and then I'm just going to hit the x squared button and press enter. And that's going to give me 104.74. So 104.74, you can't ask a partial person. So 104.74, your n is going to be greater than or equal to that. So we're going to bump that up to 105. 105. So 105 will be the smallest sample size with that confidence level. And it's going to be option A.